All right, today we're on lesson 39, which is the difference of two squares, and then some more properties of parallelograms, specifically a rhombus. Remember, a rhombus is a parallelogram with four equal sides. So if you look on page 176, the first example is 4x squared minus 9 is equal to 0, and it says to solve it by factoring. So this is obviously a different kind of factoring problem because it's a binomial. We only have two terms. It's not a trinomial like we've had in the past. And if you notice, this is a perfect square. We know the square root of it is 2x. And this is a perfect square. We know the square root of it is 3. So it will always factor like this when it's a difference of two squares. You know it's a difference of two squares because there's a minus in between the two of them. So the way it will factor is you take the square root of the 4x squared, which is 2x, and it goes here and here. And the square root of the 9, which is 3, goes here and here. And in order to get a negative, one is a positive, one is a negative. So now if you don't trust yourself, you can multiply this out using FOIL. 2x times 2x is 4x squared. The outer is minus 6x, the inner is plus 6x, and then 3 times negative 3 is negative 9. So those cancel out and leave us with 4x squared minus 9. So that is the correct way to factor it. So remember from yesterday's lesson, when we have the zero product theorem, then we take each factor and set it equal to 0. So 2x plus 3 is set equal to 0. And remember, I stressed to you not to skip this step. And now we're going to solve it. So here we'll subtract 3. Here we'll add 3. So we have 2x is equal to minus 3. 2x is equal to positive 3. Divide both sides by 2 in each case. So x will be equal to minus 3 halves. And x will be equal to positive 3 halves. It's called the difference of two squares. Okay, so we have another example on page 177. 81m squared minus 25 equals to 0, and we're supposed to solve that by factoring also. So now remember, the first step of any factoring problem is to look for a greatest common factor. Well, there isn't one, but always do that, because if you don't, the problem will not be factored completely. So we know that this is a special one because there's only two terms, and we do know the square root of this is 9m and the square root of this is 5. So we simply put the two parentheses equal to 0. Square root of 81m squared is 9m. Put it in both of the first positions. The square root of 25 is 5, goes in the second position. 1 is a plus, 1 is a minus. Okay, and then the last thing we do is set each factor equal to 0. So subtract 5, add 5. So 9m is equal to negative 5. 9m is equal to positive 5. Divide both sides by 9. So m is equal to minus 5 over 9, and m is equal to positive 5 over 9. All right, so that's it for difference of two squares. The next thing we're talking about is the properties of a rhombus. And if you'll look on page 178, it says a rhombus is a parallelogram whose four sides have equal lengths. So if you draw a rhombus, all four sides have equal lengths. The diagonals of the rhombus bisect the angles of the rhombus. So if I draw this, this is congruent to this. This is congruent to this. Same thing with this one. This is congruent to this. And we'll just put one tick mark here. And these two are equal. The diagonals of a rhombus are perpendicular bisectors of each other. Okay, so that means that these angles right here are equal. All right, now, because we already know in a parallelogram opposite angles are congruent, then what I can do is take one of these tick marks off because this is equal, these two angles are congruent, opposite, and I can take these out of here and replace them with just the one with the one tick mark because the opposite angles are equal. Okay, now perpendicular bisector, remember yesterday we said that this was congruent to this and this piece is congruent to this piece. So that's for a rhombus. The big difference is this perpendicular in the middle. All right, so bottom of page 178, we have this drawing. And it says DEFG is a rhombus. Okay. The measure of reflex angle the reflex angle is 280. So this angle outside here is 280. And if that's 280, then what's left right here? It would be 360 minus 280, which is 80 right here, okay? Find A, K, A, X, B, K, and C. All right, so let me draw another diagram up here with the diagonals in here. So if this angle is 80 and I drew the diagonal, then we know that the diagonals bisect those angles. So this must be 40 and this is 40. And then we have the other diagonal right here. And we know that all four of these are right angles. So angle C has to be 90. We just found out that A and X are both 40. And so the only thing left would be K and B. All right, so if this is 90 right here, and this is 40, what's left here is a 50. And remember, if this is 50, this also has to be 50. All right, so that's K and B. K is equal to B is equal to 50 degrees. All right, so let's see if there's one in the homework like that. Number 22. That's just a parallelogram, so that's from yesterday where the 3y plus 4 would be equal to 11 and 2x plus 3 is equal to 13. That's not a rhombus, so there isn't one in this homework assignment that has a rhombus in it. Okay, so this lesson will be due on Monday since we don't have class on Thursday or Friday. And if we're in class, then we'll grade the homework in class. And if we're not, then I'll put the answer. The answers actually are in Canvas already. You can grade them. And I'll put the button in Canvas as soon as I can get in there so that you can upload those papers. All right. See you tomorrow.